Hello everyone, we are going to analyze this pin and this plate with a frictional contact in both Ansys and Abaqus to find out which one is more effective and efficient. So I have imported this geometry into my static structural through dragging it, this analysis system here, and then what I have automatic is my materials are selected automatic and my contact is established automatic along with my assembly as well. These are the steps that I would have to do in Abaqus manually. Um, well, let's just do it in this one with a 0.25 and then give both of these a mesh size of 1 inch. It was supposed to be an inch. 0.1, and we're gonna fix these two sides and then apply, and the displacement of this pin on these faces, we're gonna restrict it. Now we set up the solver type analysis settings and solver type to be direct with large deflections on because it's frictional, and we don't know how much it's going to deflect anyway. So we let the auto time stepping on with time, and the initial time step is 0.1 with the highest being 1. Okay, and so this pin moves 1 inch in Z direction. Now we are set up to hit the solve button, and you see that meshing was really quick, and it's gonna take some time, so let's pause it and then we will resume it when we are here again. In Abaqus it's a little bit different than Ansys. So when I imported the file into when I imported the file into the Abaqus, it just gave me two paths. There is no assembly. My assembly is still empty and I would have to define it again. And there is no contact that is automatically established or material that is generated. So I am going to create the material and then create a section and then apply it to both of the bodies, and then create a manual assembly. So let's start by creating the assembly, for example, and then okay, and let's create a mesh, and the part should be 0.1, same as we did in Abaqus. But you see that now it's showing you yellow because it can still be split into different parts and cells, and we can create a better mesh. Okay, now let's split again. This is the feature that you cannot have in Ansys during you had the structural. Now it's green, now it's all good. So let's create a part with 0.1 and then we'll check the mesh quality later. So, and there is another pane that you have to create the contacts manually, and I'm just using to find automatically, but let's see, I would still have to give out the contact property or interaction property. So this is my interaction, and then I'm gonna hit contact and tangential behavior, that is penalty, and now it's 0.25, same as we did in Ansys. Hit OK, and let's leave everything off as default, and OK. Now we have one contact. We still have to define the materials and create a section. Now we create material elastic and Young's modulus. Since it is an inch system, so should be 2.1 high power 6 or high power 5 in megapascals, but in PSI it's 2.9 high power 7, and it's the same 0.3. Now I have to create a section that is homogeneous and using the same material, and then apply to them and then to this body. Now this thing is automatic in Ansys, and in Abaqus you have to define it manually. And moreover, another thing, you have to create a job, and that is also a few clicks more, and number of domains 6. Yeah, submission full analysis. Okay, now I would have to submit, and then it will run the analysis for me. Now when the an answer when the solver is running, I cannot check the results in Ansys. I cannot do anything until it finishes, and then I can see like where the results are going or the trends are going until it submits all of its results. But that doesn't happen in Abaqus. In Abaqus, I can check the results while it's running, and I can even use and fix these things and go back and then kill the job and then change everything. So if some of these things is wrong, and I would have to wait until it's too late. Now one thing we did not do in Abaqus was to create a step. Now without a step we didn't do anything, and let's create a step with 0.1 and the maximum of 1. Okay, now what we didn't even specify the boundary conditions. Well, let's do it. One, two, all of it is fixed now. And there is another boundary condition that we're going to create, and that's the displacement of this thing. See how everything is named, created a set in Abaqus. So I can create a set manually and then use these sets to apply the boundary conditions. Okay, and in the step 1 I'm gonna move this thing to 1, so it's in Q3 1, and that is in positive direction, right? So we write input again and then submit it. We're not using the GPU acceleration yet. Now as compared to the Ansys, you don't see this the convergence plot or the graph, so it shows you here, and but in Abaqus it shows you this thing with this description. But let's see the main thing. So with the Abaqus, the user time is 161 seconds, system time is 5.6, and total CPU time is 167 seconds. And oops, in the Ansys, a total time of 592 with a CP time 3034, and this is the details of elapsed time computing solution 581. Now compare that to 167. Let's check the results. Okay, the formation, directional, and in Z. Results, and find out not the mices. We're gonna find out use magnitude u3, and that is 1 and then 1. So let's compare that to it. It's fairly the same. And let's look for the stresses. For example, mices are 5.5 high power 6, and but here is a distinction. The abacus is non-dimensional. Like, you have the input dimension and then you just carry on with it. You don't get any dimensions over here. You would have to know that it's PSI because the input of your model was in PSI or inch system. Now the Ansys has it in PSI 1.02 high power 7. That's a little bit different, and that can be because of the mesh. Now let's check on the mesh. Like, what was the mesh? Now mesh show detailed card, and all of the elements are hexahedrals. 10,248. And what was our mesh here? So it's 20,640, even though we use the same body sizing. But because you could split it into, in the abacus, we could simplify our problem for meshing, and we get half as much elements. We get half as much as elements for the same mesh sizing, for the same geometry, and for the same problem. And imagine like how much time uh, did it take. Now let's try solving the same problem with the GPU on. I don't have a very high fi, but let's try with it. Okay, it gave me this error, and let's read it. So it said, while one GPU has been detected on this machine, no recommended GPU devices have been detected. So only these ones are supported. And I don't have one of these. I have P2000. But let's see what Abaqus does with it. Edit, and then parallelization, GPU, and then submit. But we still have to remember how much time it takes, 167. Now we will compare it with the analysis on the GPU. Now we see that the GPU is already running on it, and it's solving. And we can also check it with from here. Oops. Yeah, GPU acceleration enabled. Okay, now we're gonna look for just how much time it took here to finish it. It didn't even start yet, or it did finish. Yeah, 106. Imagine 167 compared to 106 versus 500 and something with here. Thank you for watching. Have a good day. Bye bye.